Today I will talk about cis and trans isomers. We call them geometric isomers. It's two compounds that are exactly the same in terms of elements, but they have different properties, physical properties, chemical properties, and physiological properties. So in terms of formula, if you look here at that compound, you have C double bond C. It must have C double bond C. And the trans one also have C double bond C. This is a must. And then look how many carbons do you have? You have C2. And how many groups do you have? I have two A's and one B and one D. Trans must has exactly the same. So also C2, two A's, one B, and one D. The differences here is, if you look at the cis, it has two groups A's at one side of the line. So you have a line here on top of the line or underneath the line. This is a must. So each one carbon of the double bond contains a group A and the other C contains another group A. Whereas in terms of trans, we have one carbon of the double bond. It has one A and diagonally there's another A on the other side, on the other carbon. Let's have an example. First of all, we look for the C double bond C. It is there, perfect. And then we have one Cl, one carbon of the double bond, and another Cl on another carbon of the double bond. So we call this one, this is a cis. Other example for the trans, C double bond C, is first thing to look for. And in one carbon of the double bond, we have a Cl, and diagonally on the other carbon of the double bond, we have the same Cl. Cis, call it trans. It doesn't have to be Cl, it can be anything. It can be Cl, Br, iodine, methyl, ethyl, phenyl, anything, but they must be the same. Again, you have C double bond C. One carbon of the C double bond contains methyl, and on the other carbon of the double bond, another methyl. So we call it also cis. Another example, C double bond C. One carbon of the C double bond contains methyl, and diagonally there's another methyl. This we call it trans. Another example can be Br in one carbon connected to the double bond, and another Br on other carbon connected to the double bond. So we call it cis. Also, you can see hydrogen as well. Somebody may say hydrogen got the same. I agree. In one carbon of double bond, get hydrogen. On the other carbon double bond, you get another hydrogen. So this is another way. This is to prove this is cis. Trans, C double bond C. We have Br in one side, and opposite side we have another Br. Or similarly, I can say hydrogen and hydrogen are opposite as well. So this is trans. Another example, C double bond C. Then in one carbon, it contains ethyl group, CH2, CH3. And on the other carbon, contains exactly the same CH2, CH3. So this is called cis. Example for trans, C double bond C, and in one carbon of the C double bond, it contains ethyl group, and on the other carbon of the double bond, oppositely or diagonally, it contains exactly the same group, ethyl. So we call it trans. Be careful. There are some example a bit, they might look like are cis and trans, but I'm not. I'm gonna give you example of those one. C double bond C is a good sign. Okay, and then if you look here, you can say, oh, I have Cl in one carbon and another Cl on the other carbon. So this is cis. No, because on the same carbon here, I have Cl and also I have the same group Cl. So whenever you have one carbon of the double bond contains two exactly same groups, this is wrong. This is not cis or trans. It cannot be, because this is on the top of the line, I have 2 Cl. So I'm gonna say this is cis. And then also I have Cl diagonally with this Cl. So this is trans. It cannot be cis and trans same time, whether it's cis or trans. Another example, I have C double bond C, beautiful. And then I have a Cl and I have another Cl. But careful, both of them are on the same carbon. Again, two elements or two groups on the same carbon of the double bond, they are not cis or trans. Finally, if you have a C double bond C, and there is no repetition of any groups or element. So I have Cl, different than Br, different than iodine, different than methyl. So there is no group similar. So I can say this is a big no-no. This is not cis nor trans. Thank you for watching.